All right. So just a quick introduction to Rigetti. So we are a full stack quantum computing company. Our mission is to, build the world's most powerful computers to solve some of the most challenging problems that face humanity today. Everything from, logistics to pharmaceuticals and you name it. Um, just a quick snapshot of our product offerings. They run the gamut from full quantum computing systems all the way to application services. This is quite a bit expanded since the last time I presented here at the Fabrication Services uh, workshop. Today, I want to focus on this second box here, our QPUs and Foundry services. I am happy to talk about any of the other boxes offline, but in the spirit of fabrication and hardware, I want to focus here. So our hardware offerings, I would say they're kind of bifurcated into these two categories. One is our QPUs, so these can range from our 9-qubit system, termed Novera, all the way up to 84-qubit systems, which we have deployed over the cloud. But people can actually buy these. So if you're a national laboratory or you're a university that you want to get your students up and running with small-scale QPUs, this is a great place to start. Many of you who have been keeping track of our Foundry services already know about our fabrication services, but I'll touch on those briefly. So we do have Foundry services where folks can submit their own superconducting quantum device designs, and we will fabricate them for our customers. So underpinning a lot of this hardware is our Fab 1. So this is our purpose-built superconducting quantum circuit manufacturing facility. It's based in Fremont, California, in the Bay Area. And really, this Fab 1 underpins a lot of our hardware development that's gone on the past few years. A couple of key things that it enables us to do is we call this hardware innovation flywheel, where we design a chip, fabricate a chip, and test a chip. And we can do this with significantly faster cycle times than your typical CMOS or MEMS foundry is able to do because of the vertical integration. This vertical integration and having this fab in-house also minimizes, a supply chain risk. It drives a lot of the efficiency in scaling our architecture, which, if you've been paying attention to our roadmap, it will heavily utilize our pioneering chiplet technology, where we're taking multiple dies and making a unified quantum processor out of those dies. Probably most importantly for this forum is our R&D partnerships that this enables. So we've been able to leverage Fab 1 as an asset to deliver value towards or to our customers and our partners, which range from national labs like Fermilab and Air Force Research Lab to universities such as Purdue University and others. So you might be wondering, why Foundry Services? Why offer your fabrication facility to the outside world, right? This is a key piece of our IP. But really, it comes down to the parameter space of research problems in the quantum hardware area are just too large for any one organization to solve on their own. So we really wanted to enable these researchers in academia and national labs and other companies to focus on these problems of interest, whether it's new qubit geometries, new gate schemes, new coupling schemes, maybe different kinds of amplifiers from JPAs to TUPAs, etc., and remove the fab aspect from the fab variability aspect from there, right? So if you're working in a university clean room, these tools are shared. You don't know if someone's put in, gold or some other, some dielectric material before you do your processing. So removing that variability is a great boon to these researchers that aren't focused on the fab aspect of things. So in doing so, we want to help accelerate quantum innovation, across the board. So I also wanted to give a snapshot of what is possible. So I really these left two columns are what we would call our prototyping services in a sense. So with our foundry, like I mentioned earlier, we have a PDK, a process design kit, that has layer definitions, what corresponds to what metal, what certain features are fabricatable and what aren't. So folks can submit designs. We can allocate these designs onto a multi-project wafer and then manufacture the devices for our partners and customers. For the Novera, so this is actually relatively new. We launched this in December of 2023. And really, it's I would say we've seen the market around this develop kind of in three different areas. So one is other quantum companies. So folks that are developing quantum software or control electronics, at some level, they need real QPU hardware to run on. And there's only so much you can do over the cloud. It really helps to have your own system, behind your own firewall, very tightly integrated with your own computing infrastructure. Second is the academic market. So these are schools of engineering or departments of computer science that want to host a QPU. They want to get their students learning on it, not just from an algorithm perspective, but also from a hardware perspective, right? What sort of mechanical engineering considerations go into building this whole system? A QPU is much more than just a chip. There's a lot of cryogenic components involved. Of course, there's the dilution refrigerator, but there's also amplifiers, signal conditioning components, the room temperature control electronics that actually deliver the microwave pulses to control your QPU. All of this can be manipulated and swapped in and out and customized. So really, this Novera is a really good prototyping platform for a full quantum computing system. And then you can add to that as well. I mentioned larger scale systems like 2484 qubit. We've demonstrated that at the NQCC in the UK, where they are customizing essentially the combination of fridge, control systems, chip, and so on. So I'll stop there. I think I'm close to my 5-minute time. But yeah, to highlight, Foundry services and Novera are really, really powerful, we think, for the field in terms of driving research forward and enabling people to get their hands on quantum hardware and increase the pace of learning and workforce development. Thank you.